Is it recording? Oh, good, we're recording. Riley and Elizabeth, if you're home, I basically just talked about all this stuff. Sorry you missed it. So this text says we have a vertex at negative 2, 0. And if we use symmetry, where's the other vertex? 2, 0. And we have a focus at 3, 0. So where's our other focus? Negative 3, 0. Pretty simple. Now, we're going to find these equations of our slant asymptotes. We're also going to find B. We do need B to do the slant asymptotes, right? And do this little box out technique so we draw properly. But let's go ahead and find B. Now, we need to talk about where we get two of the letters here. What's this 2 to us? A, right? That's A. Now, this point, negative 2, 0, 2, 0. That gives us our A value. How about this 3, 0? That's C. Focus. That's C. And we just use our new form where B squared is C squared minus A squared. So B squared is a 3 squared minus a 2 squared. That's 9 minus 4. That's 5, isn't it? So B is plus or minus root of 5, which is just a little over 2. Something over 2. Doesn't have to be perfect. You can go to your calculator if you want. I don't really care. It's just a little over 2. So we're going to go up to 2, just a little bit past. I'm going to put a little point there. And then we're going to write in our slant asymptotes. We have y equals b over ax and y equals negative b over ax. All right, so we figured out b was this root of 5. Man, I guess I do need to do the decimal. That stinks. Root of 5 is 2.23. I'm going to divide it by a, which has a value of 2. And there's no way to convert that into a fraction, which kind of stinks. It's about 1.12x. This means we have a slope of 1.12. I can probably take that 1.12 and approximate it as a fraction. But I don't think it's going to help me on my little grid. Rise 28, run 25. That really help me on my little graph? Not really. The negative b over a is about negative 1.12x. So for our little graph, I guess we're just going to have to rise a little over 1 and run 1. Just a little bit. Just rise a little bit over 1 and run a little bit over 1. And rise a little bit more and run a little bit more. It's not going to be perfect. And dash this thing out. I swear when I was a kid that Miss Buckley always told us just to draw perfect slanted lines that went right through the origin, up 1 over 1, because they end up being so close to 1. On a freehand graph, it doesn't really matter. Anyways, there's my slant asymptotes. And what we do is we box out with that other almost vertex. And that helps us draw this thing. Deal is don't touch your slant asymptotes. Yeah, you got hyperbola. Now, what you draw, does it need to have those dashed lines in it? No, it doesn't need to have those. That would just make your drawing look ugly. So don't put them in there. Was that so bad? You might have to look at your notes as you do these. Maybe that's a drag, I don't know. You might be able to find a TikTok video on it. What I see y'all glued to all the time. All right, so one more. Then we'll move on to y-axis centering. So what's A? 4. What's B? 2. And B squared is C squared minus A squared. Isn't it? Yeah. So I square 2, I get 4. I square 4, I get 16. I add 16 to the other side, I get 20. I take the root of 20, I get plus or minus 2 roots of 5, which is about useless. That's about 4.5. Let's see what our slant asymptotes look like here. I think they're actually pretty good on this one. Seems like y is either b over ax or negative b over ax. Is that right? Told you I was pretty rusty on this. So this one's actually useful. These are numbers we can work with, aren't they? 1/2 and negative 1/2. So those are useful. And we'll start drawing. I need to go out to 4. Why do I need to go out to 4? That's A, right? It's your vertex, which means I also need to go out to negative 4. Your focus is just a little bit ahead of that and a little bit behind that because it's at negative 4.5 and positive 4.5. Are you okay with that? Or do I need to write out the ordered pairs? So they're just a little bit ahead and a little bit behind. And we're going to do the box out technique. B was 2. That's nice. So I'm going to box all the way out to my vertex. And the truth is, once you box out to the vertex, there's really no reason to talk about these equations because the boxing handles it. You know, if the slope is 1 over 2, you rise 1, 1, 2. And then you rise another 1 and run 2, and where do you end up at? The corner of the box. That's kind of how that works. So the boxing is probably what we did when I was in pre-calc in high school. But I was 16 years old. I don't remember much of what I was taught then. I do remember drawing boxes. And that's the gist of it, kids. Just try and stay close to the box until you work on that slant asymptote and work your way along that slant asymptote. You do it on both sides. I didn't take this box out far enough on the left. I also ran out of paper. So how's this stuff going? I'm sure that, day one of parabolas, it seemed like it might be a little rough, but has it gotten progressively easier? You know why? You got accustomed to the forms. That was the only difficulty. The difficulty part is getting accustomed to forms. Once you get accustomed to them, that you start realizing that they're all so closely related and they're pretty easy to work with. So we did transverse axis was the x-axis. Now we do transverse axis the y-axis. They open up and down. And it's a lot like yesterday. These equations are actually written with y first as opposed to x. Other than that, they're the same thing. They really are. A is big. A goes with Y. That's your transverse axis. When you see A under Y, or you see the big number under Y, it's telling you you open how? Up and down. So that's the gist of it. Everything else stays the same. So here's an analyzing one. And it is not in the form it needs to be in. Big deal. What's that number? That constant's supposed to be 1. So you manipulate a little bit. You want to be good at manipulation. Because if you're telling me you don't try to manipulate people, you are a liar. Anybody not ever tried to manipulate somebody? The first person you ever tried to manipulate was your parents. You were 2. They told you no. You threw the biggest temper tantrum in the whole wide world. What did my kid throw a temper tantrum over yesterday? I wouldn't let him throw rocks. It wasn't that he was throwing rocks, it was what he was throwing rocks at. Meltdown. Then you got to reset the darn kid. Me. That was the problem. And they weren't little rocks. Because I had a load of 6 and 8 inch rock dropped off at the house. They were big rocks. He was picking up the 4-inch rocks. It wasn't like little rocks from a driveway. It was big rocks. That was the problem. If he'd have thrown him anything else, even his mom, I wouldn't have said a word, but they were at me. So we had a problem. So here's our equation. What's A? 2. A is 2. A is 2. And this big number right there, the big number under Y, says up, down. Make sure you know that. The big number under Y says up, down. If the big number is under X, left, right. What's B? 1. How do we find C? We just plug the stuff in. So that'd be 1 equals C squared minus 4. That's 5 equals C squared. So C is plus or minus the root of 5, which is like 2.25. I'm going to check that. It's probably 2.23. 2.23. So we probably won't rely too much on our slope equations because that's pretty hard to graph on a little bitty graph. So we'll probably just rely on our box technique. You okay with that? Let's just do the box technique. We are going to show the slant asymptotes. Now this is an up-down. If A was 2, where's your vertex? At 0, 2. When M's at 0, 2, where's the other one? 0, negative 2. Maddox, you good back there? You're not talking much to me. Of course, you never did. The B being 1, that gives us the other sides of our box, right? It's actually not really a useful point. It's just for drawing purposes. We're going to put a little point there, a little point there, and we're just going to box this sucker out. Now our slant asymptotes going to pass right through the edges of that box. The only other thing I haven't put on there was the focus. Focuses are just a little bit below negative 2 and a little bit above negative 2. And I can now draw my hyperbola. You guys have any issues with that? It's not going to be hard. I mean, you might have to look at your notes and look at your forms, but it's not going to be hard. If I gave you a quiz and you had to know your forms, then it would be hard, wouldn't it? I've done this a couple times. What would throw you off is when to use b squared is c squared minus a squared, or when it's a squared minus c squared. That would throw a lot of kids off. All right, so here's where we find an equation. This might be useful to y'all because you might just draw your hyperbola and you might just pick out some points. This is probably how you'll write your equations, to be honest with you. That's how I would. So we have one vertex at 0, 2. We have focuses at 0, -3, and 3, and we're supposed to graph. Well, let's write the equation first. What's that give you? What letter? A. Vertex gives you A, doesn't it? What's that give you? C. Now, I am going to plot what I have so that I know, I already do know, I'm at least visualizing it, so that I know if it's an up, down, or left, right. That's a big deal. Is it an up, down, or left, right? We have a vertex at 0, 2, which is the y-axis, Benjamin. It's a vertex. And we have a focus right above it. We also, if we have a vertex at 0, 2, we have a vertex at 0, -2, and we have a focus that's given right below it. So is she up, down, or left, right? She's up, down. She's y squared over a squared. That's our form. And the only thing we actually need to know to write the equation and to finish the drawing is b. So b squared is a squared, sorry, c squared minus a squared, so 3 squared minus 2 squared. Oh, look, guess what? It's the root of 5 again, isn't it? And the root of 5 is just a little past 2. So we box out. Does everybody understand the box out? Drawing a box that encompasses the two vertices and the b value. That's all it is. What passes through those boxes? Slant asymptotes. They are the diagonals of the box. They constrain the parabola. I keep drawing mine so that they somehow angle in. They never angle in. I don't mean to do that. They always stay angled out. Always angle out. And if I was doing this as a project, actually, this is not the question I had in mind. I'm sorry. I was thinking about one where a point was known. 11:10. How long are y'all in here? 11:21, 15, 13. We need to be done because I can't do another one. If I'm not here tomorrow, the notes will be finished. The video will be posted on Google Classroom.